Hello, um, and welcome to this session by Prof. Touradj Ebrahimi. It's my honor today to present Prof. Touradj Ebrahimi, who is a professor of image processing at École Polytechnique Fédérale de Lausanne, where he actively teaches and does research in multimedia signal processing. His areas of research and interest include image and video compression, media security, quality of experience, and AI-based image and video processing and analysis. He does a lot of things. He's involved with the government, academia, and industry. Just for instance, he's the director of multimedia signal processing at EPFL. He founded several startups and he's heavily involved in the JPEG community, as he is the governor of the JPEG standardization community, and he is an initiator and leading member of the JPEG AI and JPEG trust standards, with the aim of developing trustworthy media solutions. Prof. Ibrahimi is the inventor of 15 patents and over 500 publications. So hopefully today we will learn from his vast experience about the opportunities and challenges around machine-centric image processing and generation, and how the JPEG community proposes to navigate these innovations through standards and interventions. So, Prof. Ebrahimi, the floor is yours.
Thank you very much, Dr. Taïk. You're very kind to your description of my activities. I've been in this area for 30 years, so it's not very difficult to cover many areas of topics that touch image processing. But today I'm going to be a little bit high level without going into details, and I'm going to talk about especially two standards that exist thanks or because of these recent interests in artificial intelligence. Now, the main reason I decided to talk about these two standards are that one of them really takes advantage of all the good things that AI is bringing, and this is called JPEG AI. It's an image coding standard. I'm going to start with this one and a little bit motivate and give you some ideas about what it is and what it can do without entering too much into technical details. But then I'm going to talk about another standard that is developed because everything AI is not necessarily good. Sometimes there are some side effects that needs to be also addressed. And you all hear about some issues around AI, ethical issues and responsibility and explainability issues. And this standard that is called JPEG Trust is to answer these, at least some of these challenges. So without any transition, really, let me start with the main motivation that made experts involved in JPEG to look at AI for coding of images. Because until very recently, until about 5 years ago, all JPEG standards, but not only JPEG, all standards around that had to do with multimedia information were designed with an approach that people like to call human-centric. Until recently, and still it's in terms of percentage, the majority of cases, multimedia is destined to humans. So all cameras of the world, all microphones of the world, until recently, they were capturing data, audio-visual content for other humans. It's only since recently with the applications like self-driving cars and automatic surveillance, automatic quality control, and many, many others that are growing, that the humans are going out of this loop. But until recently, this was not the case. And even currently, the majority of the content that is being captured is for humans. And that's why when systems are designed, whether it is to capture content, whether it is to display content, whether it is to process or even analyze and interpret content, it was always taking into account human sensory systems, either mimicking human sensory system or capturing information that was important for human sensory system. And the name of the game was, let's maximize the quality of experience that we offer to human consumers. Let's get the highest quality audio, let's get the highest quality video, let's make content as immersive and as photorealistic, as interactive as possible when compared to the real physical world. But then, well, here, the new paradigm. The paradigm of artificial intelligence, but also the paradigm that a lot of things that we use to ask humans to do for us are gradually being tasks that are being carried out by machines. So machines are becoming very important in many, many applications. And these are machines that are doing more and more. So taking tasks that were only possible by humans into their consideration, and they are doing them sometimes without even relying on any human intervention or human supervision. Let me mention a couple of them. There are many, of course, but computer vision is a very good example of that. Until recently, for example, if you wanted to monitor a street or an area, you would have cameras that would capture video of that area. They would send it to a control room full of displays, monitors, and then some humans, one or more humans, will look at these monitors and would decide whether everything is going normally or not. But that's not anymore the case, or at least not as much as it used to be. Now machines can detect objects, they can detect cars, they can detect humans, they can detect their behavior, they can detect even who what these objects are and who these people are. This is increasingly so thanks to the advances on artificial intelligence. So people talk now more and more about AI-assisted computer vision. Not that you cannot have computer vision based on alternative like model-based or more traditional approaches, just that AI is really a technology that is doing these things very well compared to how the more conventional methods were doing it. And sometimes, in fact, they even surpass the performance of humans. Let me just give you another example, because it's not only machines doing things alone. Machines can help to do things better for humans, even if the content is destined to humans. A typical example is something you have almost in every mobile phone camera of the high-end cameras, high-end mobile phones that are around, and this is usually referred to as computational photography. So, in the old days, you needed to really learn how to take good pictures, and you could not take pictures and in any condition. You couldn't take good pictures of good quality in very dark or very bright environments. And I'm sure many of you remember at least the times where people were saying, oh, don't take pictures by looking at the sun. So the sun should not be on the background of the scene where you take a picture. It should be the other way around. The sun should be behind the camera because it will help. Nowadays, this is not really necessary. And not only that, there are lots of things that you can do by analyzing the content, often using artificial intelligence techniques in order to actually make the content more appealing, having colors that are more vivid, contrasts that are better, resolutions that are very high, definitions that are very sharp, etc. This is not necessarily making these pictures more palpable for machines, but it's more using these machines to make them more appealing for humans. And that's where people often talk about computational vision, which is a mixture between often artificial intelligence approaches that are taking advantage of artificial intelligence to either help machines to analyze and understand their surrounding world through audiovisual content analysis better, or make these same contents more appealing. This has been really also intriguing, expert in coding. As you know, image, video, audio, speech coding is the art and science of trying to compact information into as small as possible volume of information, while keeping, if not all, the majority of the information that is residing in the content intact. And the method of choice nowadays in the use of artificial intelligence for coding is what I put here, that is called autoencoder. By the way, the name autoencoder is not coming from people who were expert in coding. This is coming from people who were expert in computer vision and even artificial intelligence methodologies. And what it really says is that the same way the brain in humans and some mammal works, you could actually take an image, for example, on the left, and turn it by feeding it into a deep neural network, into a space, into a representation that people call latent space. And this representation, if you do it carefully and intelligently, you could make it very, very compact. And this will be the compressed or decoded information for you. And then a dual artificial intelligence through deep neural network can be used to revert back and convert this latent space, which is very compact, back into whatever representation you started with. In this case, the same image. And the effort here is to teach the artificial intelligence to find the right weights and the right parameters in order to make the image on the left or the image on the right as close as possible, preferably even perceptually, if not even numerically, the same. And that's really what is the technology and the approach also behind the JPEG AI standard that I just mentioned to you. But there is even more that you can do. I already told you that the world is moving from a human-centric only into machine taking over more and more. And the question is, as we go, can we come up with coding approaches that are not optimizing the appeal to humans only, but also to machines? And the answer is yes, you can do that. And in fact, people have been in academia looking into what is called coding for machines. So as I told you, a lot of human-centric approaches in multimedia have taken human visual system into account. And what basically they do is that they take superfluous, that is less sensitive to human, for example, visual system or human other system out of the information, but that doesn't mean that these are not important for machines. So, the question really is, can we go and redesign while we are even changing the paradigm of the coding, the way I explained to you through autoencoder, things in a way that also machines, but not only machines, but humans and machines at the same time take advantage of it? And the answer is yes. I'm going to show that to you actually in a very, very illustrative way without entering into details. Here, a typical image enhancement that you do. So in computational photography, for example, you have an image on the left. It doesn't have a very high resolution. It's not even colored. Through artificial intelligence, you can actually enhance it. So there are methods that turn the image on the left into the image on the right, which has higher resolution. People refer to it as super resolution, but in fact, you could even color it. You could change its contrast. You can denoise it. You could do all sorts of good things that makes the image on the right look much, much better to a human when you compare it to an image on the left. Now, of course, these methods currently are taking as input representations that have been around and captured from devices we know that capture these images and video, etc. But there is no reason that this should be done like that. In fact, you could take the paradigm I told you, the autoencoder that we just saw, and instead of the right side, so the conversion from latent space to the image that should theoretically look like the image on the left, that was your input, you could actually redesign it in a way that it doesn't give you the image, but it gives you just the image that will have a better contrast, will be even colored, etc. So you see that the architecture didn't change. All what changed are the weights and the parameters that you are using on the decoder side of the autoencoder. So that's very interesting because we are at the same time doing two things, and we are doing that, in fact, in this latent space, which means that you don't need to first decode something and then start your preferred processing. You could do it directly in the latent space, which means that it's even from computational and resource point of view, it's more interesting and more appealing. The other example is the computer vision that I just gave you here. I'm just taking the typical example of face recognition. So on the left, you feed it typically nowadays into a neural network that is trained to for example, do face recognition. And then on the right side, the output is the identity that has been found, maybe plus some probability associated with it. So here again, you don't need to do it the way that is done today by feeding the network with pixels. You could again feed the network with latent space, and that will again give you a lot of advantages. One of them being that it is less resource intensive because you don't need to decode first the compressed image and then start this process. And that's really what JPEG AI is. JPEG AI, instead of saying, oh, let's be only user-centric, human-centric, or being only machine-centric, just for computer visions and vision tasks, let's actually come up with an architecture, because it is possible with the example at least that I showed you, you saw it's the same architecture. It's possible to do both. So you can actually come up with an AI-based representation, which is a single stream that is compact, but not only it can be used for human visualization purposes, so very, very human-centric, not only can be used for computer vision purposes, which is very, very machine-centric, but it can be used also for both, all sorts of processing to make images more appealing to humans, or processing to make images or video more efficiently understandable for computer vision and for machines. And this comes with a lot of advantages. One of them is that you don't create two ecosystems. You don't need to have systems and workflows for machines, systems and workflows for human in the same device, because some things are more distant for humans, some things are more distant for machines. And in fact, you can even prove that this is even a better way. You can actually, if in this type of paradigms, you do better than if you had just optimized the system for machines or just optimized system for humans. And that is really in a more technical way how really this looks like. You really encode image and video in one way, just once. You create the bit stream, and then there are many, many different ways the bit stream can be decoded. If you are just interested to visualize and show it to a human, you will use what is referred to as standard reconstruction, the middle path on the decoder side. Or if it is for only machines, so no humans, then you go through the computer vision path. And if it's for just processing, for example, to show it to humans, or later on feed it to another computer vision task, you go through the image processing, where you do denoising, super resolution, etc. Now, JPEG AI, just to give you a little bit some information about what is its status, it actually has two versions. The version 1 is almost done. It addresses mainly the core, which is let's do as much compression as possible and be as efficient as possible. But there is a version 2 that is down the road, and this version 2 allows not to do even more with time. We are learning. AI is an emerging field. Every day you wake up, there is something new. So it would be a mistake to stop the effort, but you don't want to wait too much either, because you could already take advantage. So version 1 basically gives something immediately to the world so that something efficient can be done. But since we know that you can do it still better, there is a version 2 that is down the road that will do even better than what is possible today. And in addition to that, it will allow some of the other things that I mentioned to you, like efficient computer vision tasks, efficient processing, etc. In terms of a timeline, version 1 actually just became what is called committee draft in the jargon standards, for those of you who might be familiar. And the international standard actually is expected to come in about a year, actually even less than a year from now. So you could start seeing some products and services around JPEG AI around that date, maybe sometimes even a little bit before that. Now, even that version 1 comes in two flavors. One is more oriented to lightweight operating points, where, for example, you have a mobile phone or battery-based approaches, but also there are servers that can use this. So if you have a server or more powerful, maybe also not battery-based approaches, you have also high operating point. Obviously, for high operating point, you get a better performance than for lightweight. But lightweight is very important because mobile phones and mobile in general are very, very important use cases. And in fact, here I'm just giving you, and I'm not going to show you any of this. Maybe this is being recorded, and probably there will be a way you could even always contact me if you want to see more of this or more details. But on the left, for example, you have a mobile phone. It's not the most recent mobile phone. It's Mate 50 of Huawei, and you see that actually these images that are being shown in here, they are actually all encoded, decoded on the mobile phone. So in fact, it's even possible to do that even with not the latest mobile phones in the world. On the right, you see the same thing, but I'm not gonna do that for an iPhone 14, which is again not necessarily the latest. The version 2 is going to come a little bit later, just for your information. It's going to be more or less frozen around April 2026. So there is a little bit more time for that, since the world is going to receive something to be happy with. You don't want to rush to go to a second version. So it's going to follow with a couple of years of distance, and the international standard will be sometime in 2027. But something even more is coming. Now, let me switch gears. I told you I'm going to talk about two things, and for the interest of time, I would like to tell you a little bit more about the motivation that brought JPEG Committee to not only look into how to take advantage of AI, but how to also mitigate some of the risks that AI is arising, at least in the imaging applications where JPEG is active in. And it's undeniable that artificial intelligence, especially in the field of imaging, has opened absolutely amazing opportunities. A lot of movies nowadays that you watch, they are actually using artificial intelligence in creating the content. You have a lot of processing that allows you to make better images with better contrast. You could increase the resolution and decrease the level of noise and make the colors much more appealing. You can, in fact, even take sometimes old content that is like old movies in black and white or lower quality and turn them into higher quality. There are plenty of examples of that. I'm not going to bother you. One thing that I want to show you on the lower left, maybe it's worth mentioning, this is something that is not completely out, but has been announced by Apple. This is the famous Apple Vision Pro. It's a goggle, and you see that it looks like transparent, but in fact, what you see, the eyes of this person, they are not actually coming through optical means. It's actually an overlay. It's a display that recreates the face of the person. So that what you see, in fact, the eyes and everything on the surface of the goggle is actually AI generated. And at least since, although the device is not out, there are examples of how it can be used, and many of the examples are that since there is no camera to show you, and it wouldn't be very nice to show you with your goggles on, you could actually generate through artificial intelligence your head and shoulder in an appealing and nice looking way, and animate it through just voice. So there are a lot of things that are actually happening around the use of artificial intelligence in imaging. But of course, it is not all good. For example, the generative AI, which is one of the artificial intelligence approaches to imaging, and not also only imaging. In fact, ChatGPT, for example, is also using the same technology for text, is being misused also a lot. So typical examples of a lot of content that try to create fake news is seen every day. And the question is, well, how do we deal with this? How can we, when we see a content now, how can we know whether it is real or it's fake? And there are many ways you can do that, of course. But the world of imaging actually, even before artificial intelligence becomes so prominent and so effective, had dealt with this. In fact, the media manipulation, image, video, even audio and speech manipulation is something that has a very, very long history that dates back to even prior to the invention of photography. So I'm not going to, again, for the interest of time, go through all the history, but just know that the world of imaging has been faced with the challenge that images can be manipulated. Now, more recently, of course, you could use artificial intelligence to do that, but if you go back, even when photography wasn't available and it was just painting and things like that, you could still ask humans to fake paintings and, in fact, even change the content of the painting. And because of that, solutions were put forward. And so the world of imaging is pretty familiar with how to face this, this phenomenon of manipulation of the media. But also, we know, and the world of imaging is conscious that manipulation of media, manipulation of content, can have a very, very nasty consequences, not only politically, but also socially, and even sometimes economically. You could actually fake somebody's ID and go ask for their bank account, get their money, pass yourselves as them, do things on their behalf. And these are all, of course, things that you want to avoid. And the problem is not only technical. In fact, recently, because of this phenomenon of the misuse of artificial intelligence in manipulation of audiovisual content, countries around the world are starting to look at legislations even to somehow outlaw or put at least some framework around what you can and what you cannot do. So not to, of course, forbid the good use of artificial intelligence, but put some measures in place so that you could prevent their misuse. The examples are actually everywhere, right? So some of the leaders and leading countries in artificial intelligence are actually working on that. An example is a very recent executive order by President Biden that has actually requested that there should be even standards set and legislation put in place so that any content that is generated or partially or completely by artificial intelligence should be signaled. And the same actually in last summer, so in summer 2023, China even did that also on their side. And interestingly, also they request that any content that is generated or manipulated by artificial intelligence should be signaled as such. And in Europe also, which is very concerned and has been actually starting doing that even before everybody else. And just a week ago, at least politically agreed to go ahead with an approach to put a framework, a legal framework around artificial intelligence called EU AI Act, also is requesting to signal when artificial intelligence is used to manipulate or even synthesize from scratch content. So you see, even though the approaches, the rest of the approaches and the way things are done in legislations around the world, whether it is in North America like United States, whether it is in Europe like EU AI Act, or whether it is in Asia like China, all of them seem to have some common desires. And this desire is this proactive approach of saying, hey, let's find the provenance of the content. So not only necessarily content that is manipulated or generated by artificial intelligence, but just any content. So you want to basically have trails of the content since its creation all the way to its consumption. And these trails, you want to signal them in a safe and reliable way, and do it not only with content that is generated or manipulated by artificial intelligence, just any content. The same way you receive an electronic contract and it has a digital signature, and the fact that it has a digital signature makes you, and even legally allows you to consider that as being legally binding, whereas if it doesn't have a signature, just a file, then you would say, okay, so this is just a file. I don't know if this is really approved or agreed by whoever is supposed to agree on it, because I don't see a signature. So the same approach is used for the provenance in imaging. Here, just an example. It's not even necessarily an example that is taking into account artificial intelligence, but you want to have some sort of provenance standard that will tell you, okay, even if you would take a picture from a camera, it should actually tell you which camera was used and in which conditions that it was taken, in which format it was taken. And then if somebody goes even the photographer and changes it, modifies it, crops it, white balances, codes it, changes its formats, these trails should all remain there. And then when it is even going out of the control of the photographer, for example, is put on a social network, and then some other people maybe download it and then further process, you want to actually trace all these, and at every time have it in a secure way signed with the information about what happened to it, while at the same time, of course, protecting and being aware of protection of the privacy. So all the, for example, who took the picture maybe is not as important as which type of format this picture and which resolution it was captured. And this is exactly what JPEG Trust standard is. So JPEG Trust is a standard that is actually like a framework. It allows you to verify authenticity of the content, provenance of the content, and therefore integrity of the content. And the way it is done is through annotations that could be put as a watermark or as a metadata or put on a blockchain, doesn't matter. But what matters is that it should be reliable, meaning that you should be able to, that in a secure way, if somebody goes and changes this information, then you should find out about that. Of course, it's easier said than done, but it has a number of core principles. One is that JPEG Trust is a framework. So it has many tools. Not all the tools are needed for all applications. So it has some building blocks. I already mentioned, and I cannot insist enough, that all the provenance and annotation that is done should be done in a secure way, and it should be done in a way that it verifies the integrity of the content. So if these annotations are somehow modified themselves, it should be possible to do that. Also, JPEG Trust doesn't really give you the trust. It just gives you means and information for you to decide whether you trust or not, because trust is also a fluid thing. You could trust somebody or some organization or some government for some time and then find evidence that you do not want to trust them anymore. So you need to define context and also trust profiles. And of course, one of the main use cases is growing concerns around generative AI and the use of AI to synthesize or or modify content in a photorealistic way that can mislead. So particular attention is given JPEG Trust to generative AI content, on any content that is produced by AI, either completely synthesized or modified, like deepfake detection. Currently, JPEG Trust is working on its core foundations, which are basically some of the elements I mentioned to you. For the interest of time, I'm not going to go through all of the details, but just to give you an idea, on the left here, you see a media asset. So media asset means just the digital content. Often media has some content. It could be pixels in an image. It could be frames in a video. It could be samples of a speech file, etc. And often it comes also with some metadata, right? Where it was taken, and GPS coordinates if it's a picture, etc. But it adds, so basically JPEG Trust adds additional metadata that can be in two categories, either trust declaration or trust manifest. These are the trails that I mentioned to you. And these trails actually are represented based on what is called trust credentials. So these are basically information about what happened to the content in a way that is understandable both to humans and machines. And they rely, so when you receive an image or you access an image or a video or a speech file, you basically go to the trust record, you extract these, and then you compare it to some trust profiles, and it extracts for you some information by saying, for example, oh yeah, I can confirm that this picture was created by this camera. Now you could say, okay, I trust, or by this organization. It was generated by CNN outlet, and then you decide whether you trust or not. So maybe somebody who trusts CNN would say, oh yeah, that's good. Somebody else would say, no, I don't trust them. And you could imagine these trust profiles. You can change them to just almost anything. It could be, for example, oh, it was done. It was sent to you. It's a picture that was sent from your sister or brother or your parents, etc. So then you decide whether you trust them or not, and so forth. I want to tell you also how this workflow works. So what is very, very important is that when you generate or capture a media, you need actually, once you access it, to extract these indicators, verify whether these sources, this information that's given is validated or not, and then you decide, defining some trust profiles, whether you believe them or not. Yeah, so currently also in terms of technology development, JPEG Trust actually, for its part one, that is this core foundation I told you, it's pretty advanced. Actually, it was a month ago, it became a committee draft, which is basically the technology is more or less now finished. Now between now and summer next year, so again, less than a year from now, different countries of the world are going to basically analyze this standard and then vote on it. All indications are good to believe that this is going to happen. And if this happens, it's going to be a major game changer, hopefully, because East and West, or North and South, they all require some sort of provenance technology. They want to know if something has been generated by AI, it is signaled, and this standard can be used for that. And this could be a very, very good companion to a lot of legislations that could rely on JPEG Trust as the standard to validate whether something has been properly signaled or not. Okay, so let me stop here. I hope that we will have a little bit of time also to have some more interactive conversations, and I'm going to stop here.
Thank you, Prof. Ebrahimi, for this rich presentation. Personally, I've learned a lot about the current standards, and it seems that many of them are pretty recent, actually, and ongoing efforts. So thank you for giving us this preview of what's happening. Yeah, I think we can go to some questions. There are a lot of interesting questions from the attendees. I'll start with the first one. So I'll summarize it quickly. Traditional computer vision models operating on traditional image encodings are notoriously vulnerable to adversarial attacks, mainly data poisoning. So how does the JPEG AI and JPEG Trust communities handle such backdoor security attacks, such as like adversarial camouflage attacks and one pixel attack, accessory injection attacks, and so forth?
So of course, you know, there are all sorts of ways to breach the security in imaging chain. The computer vision part that I was referring to in the JPEG Trust. So I suppose this question is really through the scope of the JPEG Trust standard. Is not necessarily giving you a perfect solution for every single attack you can imagine. This is basically humanly impossible, right? So there are attacks that we don't even know about. They will come in the future. So you cannot start making standards for things you don't even know what they are. But you could do your best in terms of how far can you go, because not doing anything is not an option. Currently, and as I said, JPEG Trust will very likely have many parts, but part one, which is the foundations that I explained, is probably the core of everything else, and it will be always there. It tells you if you want or not whether the content has been modified or whether the content has been from scratch generated by some means. It doesn't need necessarily to be artificial intelligence. So let me insist this, right? So it could be even a human being who draws something, you know, from scratch, or goes to Photoshop and changes some part of, I don't know, in painting, or uses some filters provided to you by even conventional means. No matter what what is the method that you use, whether it is AI centric, whether it is more conventional model based processing, whether it is manually done by a human, or whether it is automatically done by a machine, will leave a trace, and this trace is logged in the content and embedded in the content. That's all what it does. It doesn't necessarily guarantee that you will succeed in detecting absolutely every attack. Of course, it doesn't, but it helps. And this is where the trust profiles come in, right? So you could, for example, decide that you have a detector of deepfake. Let's say today there will be a very, very interesting detector of deepfake that can detect 99%, 99.999% of all deepfakes that are generated. That's great. So your trust profile is going to say, if something is detected by this particular deepfake detector, I trust it. But imagine somebody comes up with a countermeasure. Somebody comes up with an alternative, I don't know, adversarial attack or some other ways to go around it. And then this detector is not anymore as efficient as we thought because new content start. Then it's not that you go and change the trail. You just say, the detector that I trusted before, I don't trust anymore. Because there is increasing proof that content is being generated from some date that is undetected by this detector. So this is the approach that JPEG Trust is following. So it's a living standard. It doesn't give you everything you need to trust or not. It just gives you information in order for you to make decision. And it gives you the tools for that in an interoperable and universal standard.
Okay, thank you for this answer. I like, away from specificities, we would love to know what's your vision about the computer vision field as a whole, and whether you think like we will just continue in deep learning, or like you see maybe like some return of some traditional feature engineering techniques, or I don't know, we're just curious about that.
But that's a good question. I have to answer to you in two, if not even three different ways. So first of all, one thing that is sure is that the computer vision as we know it today is going to evolve. Whether it is going to be AI-based or not is secondary. For the mere fact that the type of content, representation of content that is being analyzed by computer vision is going to change. Until recently, and today it's pretty much the case, images are made of set of pixels. They are flat. So the large majority of computer vision today is concentrated on images the way we know them, right? So a matrix of RGB or other color spaces with 3 values per pixel, etc. Well, it's not going to be the case tomorrow. We see increasingly that people are talking about immersive content. There are devices that can, for example, create point clouds. So these are new type of content. These are 3D content. These are 3D voxels. And so, of course, the future of computer vision is going to be affected if your device is capturing its surrounding world or generating content that is actually literally 3D and not anymore 2D or 2D plus time as we are used to it. Of course, there's going to be a change to the type of algorithm that are used in computer vision, and it doesn't matter whether it is AI based or not AI based. But now talking about AI in particular, and making abstraction of the fact that the type of content, the representation of content that is being analyzed is going to change. Of course, these methods, even AI methods, are going to again change, and probably in a very fundamental way. We actually already witnessed that, right? We know, for example, about a year ago, 18 months ago, a lot of generative adversarial approaches were used. Nowadays, the move is towards transformers. So the GPT, the T in the GPT, right? So we see that the world has found another approach, not necessarily putting aside the generative adversarial approaches, but a new approach that is very, very efficient. So we are putting more effort on that. So this is one path to change. And I'm confident that in future, not too far looking future, there will be progress in new paradigms in artificial intelligence that will change fundamentally how computer vision is performed, even with computer vision. But then there is the well-known shortcomings, right, of artificial intelligence. So the current paradigm is mainly a black box that learns by throwing at it as much data as you can, and then it makes decisions, and people are saying, oh, that's not good because you don't know when my self-driving car misses to recognize a pedestrian, why it happened, or if my biometric system misses to recognize a person, why it happened. Often people say, okay, we retrain, but that's not really a very efficient way of doing things. And there is no guarantee if you retrain, you don't break it somewhere else. So the explainable approach, as people call it, to artificial intelligence, an interpretable approach to artificial intelligence, are actually things that are going on now, and there will be very likely a lot of good things coming out of it. So some of the problems that we're facing with artificial intelligence, like hallucination, for example, the fact that if it is text generated by artificial intelligence, it sometimes says nonsense that makes no sense, or it actually even misleads. It's very, very nicely spelled out. It's grammatically very correct. It's very sophisticated, but it's all wrong. So these problems, hallucination, that in the case of imaging, result in people who have an earring on the left and right that is different, or they have 6 fingers, or they have all sorts of things that do not make semantically sense. These problems all going to probably be pretty much resolved thanks to an explainable approach to artificial intelligence. No, I'm not sure they will all go away completely, because there are some fundamentals in stochastic approach to or predictive approach, which is the current paradigm, that you cannot completely remove, but you can reduce it to insignificant portions. So yeah, so I don't think, if you ask me, that we go back to model-based artificial intelligence as it was exercised in 60s, 70s, and 80s, and even 90s. I don't think that the artificial intelligence is going to stop with the deep neural network or massive, complex AI with hundreds of millions of parameters and nodes. I don't think these things are going to go away. But of course, there will be a mutation. There will be a mutation. There will be new paradigms. Some of them we know already. We know that there is a very, very huge problem with the use of resources in artificial intelligence. They are very resource incentive currently, not only in their training, but also even in their deployment. And this has to be resolved. People are looking, of course, at approaches like the neuromorphic artificial intelligence. People are even thinking about using quantum computing for machine learning to make it much more efficient. These are the type of paradigm shift that will happen. But I don't think that we necessarily go back to what we had before, which is a purely model-based approach that people used to call, not even artificial intelligence, people used to call expert systems. Yeah, the if-then else's, where you would basically ask an expert, what do you think, what do you do, and then you basically put it in a workflow.
I agree. Like, for me, I see that the scale is all you need. Trend is not like going to help a lot in the development, as it's not very accessible to many researchers. So probably, yes, the way is to find something more efficient, like you mentioned, neuromorphic hardware, etc. And explainability is indeed going to be helpful to also instill trust in these systems, and because we will understand them more and we can rely more on them for decisions. I see that it's already 10 a.m. So do you have any closing remarks or notes for us? I mean, I would like to first thank you for again, for accepting our invitation and for your very rich presentation. And yes, please let us know if you have any concluding remarks.
I would like just to thank you for inviting me. And I know that, well, this is a very, very vast and very complex topic. So all what I can say is that if there is any burning question and people have, you probably can Google search me or find me on LinkedIn and send your questions through that channel too.
Thank you very much. I'd like to ask the attendees and the participants to join the networking sessions. I think you can find them, and you can also go to the expo and yeah, and just enjoy the rest of the conference. Thank you, Prof. Touradj, and hopefully we'll see you soon.
Yes, thank you, and good luck with the rest of the conference.
Thank you.